Hello and welcome to video 2 of Module 3, Atomic Theory. My name is Brock Grant and today we're going to go through some of the questions that you could be presented with in your exam. So a couple of prerequisites for this video before we get started. I would highly recommend that you look at the first video, so Module 3 Video 1 on Atomic Theory, or you read through the lecture notes or attend the tutorials so that you understand the theory behind these questions. It's also recommended that you go through Module 2 Video 1, emphasizing on periodic table and elements, as that will help you form the foundations of the topic and questions that we're going to be covering in this video. So we're going to be going through a couple of questions in two different chapters. So in Chapter 5, we're going to be going through question 18 and 22. And in Chapter 10, we're going to go through question 4, 20, and 44. Okay, so let's begin. So let's look at question 18 on page 96. So the question states, give the isotopic notation for an atom containing 12 protons, 13 neutrons, and 12 electrons. So a couple of things should be jumping to your mind right now. The first thing is remembering the isotopic notation. So remember that we have Z, which is our element. We then have A, and we have N. So remember, A is our atomic mass, and N is our atomic number. Remembering too that with our protons, neutrons, and electrons, what happens if we change those subatomic particles? So remembering that a proton is responsible for the element, a neutron will create an isotope, and an electron will change the charge. Okay, so straight away what's popping out at me now is to concentrate on the protons. So, remembering too, in all of your examinations, you will be provided with a periodic table, so let's put it to some use. So, here we have our periodic table, remembering that we've got our atomic, let me change colors for you guys. So here we have our atomic number at the top, and our atomic mass at the bottom. So, remembering from before, our atom contains 12 protons. So moving back to here, we now look for the number 12, which we find to be magnesium. So we come back up here, so we know our element is Mg. Now, we now put in the atomic number, which we know is the number of protons, which is 12. And the atomic mass, which remembering is the number of protons plus neutrons, we look at our information given here. So we have 12 plus 13, which is equal to 25, giving us the isotopic notation for magnesium. So let's look down at the next one. So an atom containing 50 protons, 50 electrons, and 72 neutrons. So again, we simply go over to our periodic table and we look for an atomic number of 50. So as we look around, we can see here we have Sn. So Sn, with the atomic number of 50, which is given here, and the atomic mass is 50 plus 72, which is 122. Okay, so let us move forward now to question 22, page 96. So quickly scanning through this question, I'm seeing that it's going to be involving 5 isotopes. So we've got a lot of mass numbers and we've got percent abundance. So that takes me to the equation that I showed you in the previous video, how the average atomic mass is equal to the mass of that isotope times its percent abundance. So, what 4 of these isotopes are, so we've been given 4 of the isotopes mass and percent abundance here. Now, the average mass of an atom of titanium is 47.9 AMU. Determine the mass of the fifth isotope of titanium. Okay, so they're tripping us up a little bit here. So instead of saying, here are the 5 isotopes and we want you to find the average, they're giving us the average, they're giving us the 4 isotopes, but they're saying we want you to calculate what the mass of the fifth isotope is. So this can be done, and it can be done using the same equation. We just have to use a little bit of algebra. So let's start getting all of our information onto paper. So the first thing we're going to do is we're going to insert all of these mass and percent values into our formula. So we have 45.953 plus 8%. So 8% is the equivalent of 0.08. So I'm going to use that. Now remember to put all of these in brackets. Plus, now we look at so we've done that one. Now we look at the next isotope, which is 46.952. Whoops, and we've got to put our units in. Times by 0.07. Plus 47.948 AMU times 0.73 plus, sorry, I'll cross these out, and the last one with 48.948 times 0.055. Now, what do we do about the fifth average? So here's what we can do. What we do is we get our calculator and we add up all of these percentages here, because we have our percent abundance. Now, with all of the 5 isotopes put together, they must equal 100%. So we do 8% plus 7.3% plus 73.8% plus 5.5%, and we subtract that from 100. And that will give us our percent abundance for our unknown fifth isotope. So if we put that into our calculator, we will get 5.4%. So what I'm going to do is I'm going to write that here. So our fifth isotope has an abundance of 5.5%. Now what I'm going to do, I'm just going to write this down here because I've run out of room over here. So it's plus our the mass of our fifth isotope, which we don't know, so we're going to put that as X, times the percent abundance, which we know is 5.5% or 0.05, is equal to the average mass of an atom of titanium is 47.9 AMU. So that means that the average is going to be 47.9 AMU. Now, our next step here is we're going to simplify all of our brackets. So we're going to do 45.953 times 0.08, and we're going to sort of solve it for all of these. So we have 3.7 AMU plus 3.4 AMU plus 35.4 AMU plus 2.7 AMU plus 0.05x AMU is equal to 47.9 AMU. Now we take it one step further. Now we could have done all of this in one big hit. So we could have multiplied everything in the brackets and then added them all together. However, I highly discourage this. The reason is that it is very, very easy to make a simple math error and you will get the final answer wrong. So I always like to just take a little bit of extra time and break it down into 2 steps to make sure that I don't make a silly math error. So I then add these values together. So 3.7 plus 3.4 plus 35.4 plus 2.7 is going to equal 45.2 AMU plus 0.05 x will equal to 47.9 AMU. Okay, so now what we need to do is we need to rearrange and solve for x. So the easiest way to do this is we have a look at our relationship here. So we go, okay, what is the relationship between 45.2 and 0.05x? So the relationship is a plus. So if we move this 45.2 to the other side of this equal sign, that plus is going to turn into a minus. So as you move it over to the other side, the mathematical operation will swap. So it will go from a plus to a minus. I'll just draw a bit more room here, so I'll just continue this over here. So it's going to be 0.05x is equal to 47.9 AMU minus 45.2 AMU, which will give us 0.05x is equal to 2.7 AMU. Now, we apply the same step here to isolate x from our 0.05. So again, we look at the mathematical operation between 0.05 and x. So between 0.05 and x is a multiplication. So as we move this over here, it will turn into a divide. So we'll go this way. So it's going to be x is equal to 2.7 AMU divided by 0.05. Now, if you push that into your calculator, you will get an atomic mass of 50. And that is the mass of our unknown 5th isotope. Okay, so let us move forward now to question 4, page 210 in your textbooks. Write the complete electron configuration for each of the following elements. So we've got manganese and gallium. Okay, so this is going to be nice and easy because again, in all of your examinations, you will be given a periodic table. So let's have a look here for manganese. So manganese, be careful to not confuse manganese with magnesium. So it's not this one. So we're looking here. So again, we count across and down. So we want to get to here. So we have got 1s1, 1s2. So we have 4Mn, 1s2. Now we look down here. So we have 2s2, 1, 2. Now we look over here, 2p, 1, 2, 3, 4, 5, 6. Now we go down to the next level, is level 3. 3s, 1, 2, so 3s, 2. Now again, we move all the way over to here, and we go 3p, 1, 2, 3, 4, 5, 6. Now we go down to the next level, which is 4s, 4s2. Now, this next part is always something that students always miss, and for me to explain why will confuse you further, so please just take my word for it until you reach further levels in your chemistry studies. But when we go to D, it is actually an energy level lower. So, we were at 4s, we then go 3d. We go 1, 2, 3, 4, 5. So it's 3d5. I know that's very confusing, guys, and I'm very sorry about that, but please just take my word for it that when you're looking at the D sub level, it's always 1 down. So instead of 4, it's actually 3. Instead of 5, it's 4. Now, our next element that we're going to look at is gallium. So gallium is over here. Now, I'll just write it underneath here. So we're going to have GA. Whoops, sorry. GA. So again, we've got 1s1, 1s2. 2s1, 2s2. 2p, 1, 2, 3, 4, 5, 6. Another technique that we can use to help us save time is, with our previous question, we looked up manganese, which is here. Now, gallium is here, so we know it's going to have the same electron configuration as manganese because it contains the same and then some electrons. So we know that it will replicate this exactly. 4s2. Okay, here's where things change. So we've got 4s2. Now we've got 3d. Now let's count them across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's entirely filled. So 3d, 10. Then 4p, and here is gallium. So it's 4p1. So the electron configuration for gallium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p1. See how much easier that is when you have the periodic table in front of you? All you have to do is just simply count across and count down. And just remember that the number for the d orbital, the d sublevel, is down by 1. Okay, so moving on now to question 20, page 211 in your books. For each electron configuration given, write the corresponding orbital diagram. Okay, so we, over here, this is the electron configuration. What the question is asking for here is that we're given the electron configuration and it wants the orbital diagram. So this is one of those situations where it's very, very important to make sure that you read the question carefully. Because the last thing you want to do is rush into it and answer it incorrectly. So, for orbital diagrams, that's our little boxes, how we do our arrows like this. So, let's look now at chlorine. So, we remember that our s orbital has 2 electrons, p has 6, d has 10, and F has 14. Now, even if you do forget this, you can look at the periodic table, and that will give you that information. So we have 1s2, so we draw one box, up, down. So we have 1s2, 2s2, so again, up, down. Now so we'll cross these off as we go. So we've got 2p6, so 1, 2, 3, so 2p6, so we have 1, 2, 3, 4, 5, 6. So remember, we fill in our orbitals based on the electron spin. So we want them all to point up. Then we go back from the beginning and we make them all point down. So we've got our 2p6. So the next one is 3s2. So again, s has one orbital. So 1, 2. So 3s2. And the last one is 3p5. So 1, 2, 3. So 3p5. So we only have 5 electrons. So we go 1, 2, 3, 4, 5. And that is our orbital diagram for chlorine. Now let us move on to the next one. Now this, actually no, I should be able to do it over here. Let's start again. Okay, so let us now move on to copper. So same deal, we have 1s2. So up, down, so 1s2. 2s2. 2p6. So 1, 2, 3, 4, 5, 6. Excuse my messy handwriting. So 3s2. 1, 2, so 3s2. 3p6. So again 1, 2, 3, 4, 5, 6. So we have 3p6. 4s2. 1, 2. And 3d9. So 1, 2, 3, 4, 5. So we've got our 5 orbitals. So 3d9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is our orbital diagram for copper. Okay, let us focus our attention now on the very last question. So, using the periodic table, write the full electron configuration for each of the following elements while circling the valence electrons. So, straight away, the first thing that should come into your head is that valence electrons are electrons in the outermost layer. Sorry, let me write this down here. Are electrons in the outermost layer. And consist of the S and P sub-level only. So let's look at Mg, magnesium. So we're looking across here. Let's find magnesium. Here we go. Here it is. So we have for Mg, we have 1s1, 1s2, 2s1, 2s2, Looking over here, 2p, 1, 2, 3, 4, 5, 6. And 3s1, 3s2. Here we go. So 3s2. So we have our electron configuration for magnesium. Now, how many valence electrons does it have? So we look at the our outermost layer, which is level 3. And we know that we have 2 electrons. So that is our valence electrons. So magnesium has 2 valence electrons in its outermost shell. Now looking at the next one, which was fluorine. So same deal, 1s1, 1s2, 2s1, 2s2, 2p, 1, 2, 3, 4, 5. Okay, so 2p5. So S and P only, outermost layer of electrons. Let us have a look. So we see fluorine here. Now, how many valence electrons does it have? Well, its outermost layer is the second level. Therefore, fluorine has 7 valence electrons. Okay guys, that wraps up Module 3 Video 2. I hope you enjoyed it and it was assisting... Okay guys, that's about it. That now wraps up Module 3 Video 2. I hope you all enjoyed it. Thank you very much for viewing. If you do have any questions or suggestions, please feel free to write it down in the comments section below. I'm going to be looking through there and commenting as much as I can. If you liked it, give us a thumbs up. If you didn't like it, give us a thumbs down. If you could all please complete the survey in the description down below, that would be absolutely fantastic. Thank you all very much for joining me, and I'll see you next time. Cheers.